Friday, we were talking about a ping pong ball, and I handed out this little worksheet, not a gradable worksheet. I made a copy of it. Another copy of it. There we go. Fantastic. There's two sides to it. Thank you. Excellent. Anyone else need a copy of it? I have one. Yours, if you have it, great. Thank you. I have plenty of copies. So the goal of this worksheet was to discuss a system and talk about it specifically using these vocabulary words. It's not simply an exercise that we're doing the first day of week 2. Week 2, yay. Week 2 of this class, and then we're going to change the chapter and never see this again. These are the types of vocabulary words that we're going to be using throughout the semester, especially in this class when we're talking about technology and systems analysis. This is how you analyze a system. It's one method for analyzing a system. However, as systems analysts, and specifically as systems thinkers, when we're done with this class, geeky as it is, this will be your vocabulary when we're talking about systems. For the rest of the ISBT time and as a professional, as the rest of the professional time. And just like you can meet fellow architects or fellow computer programmers, you will most definitely meet fellow systems folks when you get out of here. It's something that we do. So, Jay, do you know if you need a copy of this guy again? Fantastic. So, the idea of this vocabulary is not that it's foreign, that you've never seen these words before. It's just the context in which it's being used. And this is how systems thinkers work. So what we did, review-wise again, is we had a picture of the box. The reason why we put a box up there is so that we can sort of narrow down on what we're talking about. We specifically grabbed a ping pong ball. Sometimes I write the title inside the box, sometimes I title on top. Either way, but there's our little picture that we did on Friday. And then when we say this is a system, now we know what we're talking about. The idea is that that box allows us to separate what belongs to the ping pong ball and then what's outside the ping pong ball, what's not directly attached to it. Sometimes the things around it, I'll put this up here already, we already mentioned this guy, we call this guy the environment. That's everything outside the ping pong ball. So the ping pong ball is the thing inside the box. The environment is the stuff outside the box. And typically, the way these systems work is that they communicate. They somehow interact with their environment, so surroundings. You guys are interacting with your surroundings right now. You're listening to me talk, blah, blah, blah. You're in the room, you have eyes, you have senses, you can measure things. And the idea is, once we understand how these things connect with those things that are around them, then we can build things out of them. So you guys already know that a cell phone is not just one thing. There's lots of things that go into building a cell phone. There are lots of things that go into building this classroom, including all the objects you're seeing. There's a lot of things that go into building a human, a natural system, but all the different systems that we have. Once we get good at and comfortable discussing things this way, then we'll start grabbing other systems and wiring them together or putting them together. But for now, we said the reason why I draw 3 here is we specifically talk about energy that flows into or out of a box. We talk about material, and the order is not any importance. You have to memorize it. This is just this is how I'm doing it this morning. And info, and then the same way out the other side. Energy, material, and info out the other side. That allows us to describe what this system does. And then inside the box, where we say the ping pong ball is, that's when we can specifically talk about what the ping pong ball does. This is what happens inside here is how we transform or move these things on the in. Getting all these words. Things that we put in to things that we put out. input and output. And yeah, if you're a computer scientists use this all the time because this box is usually a computer or a computer program. It takes input, it does something, and then it spits out the answer out the other side. And we generically call this the process. Okay? The process typically looks like a list of things to do inside a recipe. It's typically step 1, step 2, step 3, step 4. Sometimes the steps can be optional. Sometimes we might circle back and do a different step. But these usually look like a list of things to do, which is why it's so easy to see this look like a computer program, because if you've done any programming, writing in Java or HTML or whatever, usually it's line 1, do this, line 2, do this, line 3, the whole way through, and then the process stops at the other side. So there's our big picture. The ping pong ball is the box itself, or inside the box. It has input, things come in. It has output, things come out. It has the entire environment around the outside. Have you guys ever heard of the phrase? This phrase has been around for decades, even before I was a wee little human. Think outside the box. Yep. What does that mean? Think outside the box. Has everybody heard that phrase? What does that mean? Think outside the box. What box are they referring to when somebody says, "What a great idea! You're really thinking outside the box."
Like you're thinking different than what most people would think, because there's a list of things that people normally would think of, and then thinking outside the box is something new that you wouldn't normally think of.
Sure, I like that. That phrase, "think outside the box." I wasn't there when this happened, but I wouldn't be surprised if we were to go talk to someone who was a little bit grayer than me, who was in charge of coming up with systems theory, which actually came into popular belief around the 50s. It's not ancient. It's 65, 70 years ago. The idea was, this is how I do things. I go to work. I've been trained to do my job. And I just go to work and I do these things, and I just go down this list and start at the top again, and go down this list, and then that's what I do. I'm a robot. I just process and do what I'm supposed to do. And then something changes. Either the input isn't available, or there's new input, or we need to adjust the job, or the environment changes where we're doing our job. All of a sudden, it's important to look at the entire situation, understand the environment, look at the input, look at the output. That's where we get the phrase, think outside the box. You need to look at the entire thing, not just learning how to be trained to do something. You need to open things up, and when you do open things up and think outside the box, oftentimes we'll change the process. We'll change how we go about doing things. We'll put a new updated thing.
But you have to use that environment to gain more information, to bring it in, and then to process it, to increase your outcome.
There you go. Again, I do this all the time. In charades, this means right on the nose. It means exactly. Okay, so yes, this is right on the nose. It's exactly right. This is not making fun of or disparaging someone who has a job where their job is to be a robot and do exactly the same thing correctly. Okay, there are lots of very talented people that do exactly the right thing at the right time. And there are lots of careers where you must do exactly the right thing at the right time. If you don't do it, things go badly. Air traffic controller, okay? When the plane is coming into land, in the next 30 seconds, we need to get this very, very fast, very, very heavy, very, very congested airspace plane from over there to on the ground. Okay, there's a procedure that we follow to do that. So someone who's an air traffic controller needs to follow that list. However, God forbid, there is an emergency. Something has changed. There's an accident on the runway. There is crazy weather. There's wind shear. There's a duck that refuses to get off the tarmac. Whatever, that human has to not throw away, but realize that the situation has changed. And they have to solve the problem on the fly. That's why we hire humans. Increasingly, we keep on putting robots in robot jobs, and increasingly robots are getting smarter. But a robot that doesn't have this ability to think on its feet or think on the fly, then bad things happen. Okay, so the idea of a robotic car or a self-driving car, if the self-driving car is flying down the road, God forbid, just like that in this snowstorm, and something changes, it better react quickly. That's why people are sort of wondering how that could possibly happen. We need humans in places where we have to change our thought. So I wanted to get this idea of thinking outside the box, but for now, we're going to try to sort of decide what these things look like and how they work. So this is how we use this. In addition to that, we grab these 4 words up here: natural, human-made, physical, conceptual, static, dynamic, meaning it mostly moves, it mostly stays put, closed or open. We talked about different inputs, whether they're material, energy, or information. Again, it doesn't matter what the order is. And then down here at the bottom, what's the generic process? How does this thing work? So what I want to do is, I know we're not in lab, and we're going to be doing something different for lab afternoon. I have 1, 2, 3, 4, 5. I have 5 very secret on Post-it notes systems. And I'd like you guys to grab another column that hasn't been used yet, either on the front side or the back side. And as sort of a group, right hand these guys this out. If you guys could fill out the form, the systems form that describes what this is. So let's maybe work with the lady behind you. And then maybe use that.
How many people do we have to have in one group?
100.
Oh.
Just whatever works. Maybe you guys can work together. Maybe this side. And again, it works best when everybody doesn't know what the other super secret thing is, so we can sort of get on us. But maybe you guys 3 here, something like that. And then maybe you guys, maybe the 4 of you, can be really quiet. Talk about that.
What is it?
It's not a test. It's not homework. This is oh, don't say it! Damn it! It's like shreds again. The goal is for you guys to fill out this form for that topic and describe it as a system. Okay?
They were just like baseball. Yes.
Guys don't play well. Guys don't play well. There's always a group. Unfortunately, we're ISBT, so we sort of like attract all kind of guys. We always want the out-of-the-box thinkers. This is what you get. The Mavericks. We have an entire room of Mavericks. I'm gonna go teach the drone major. We're just drones.
The rules are conceptual. The games. It's more physical than it is conceptual. The rules are. It is. It's like you gotta play baseball. It's physical. Yes, it's dynamic. It's like a dynamic.
There's only one close
Open to energies, open to materials, open Oh, he said, "Oh, they playing on the baseball court, right?"
He called it a court. I don't know. That's like slapping America in the face.
Aw.
They have Lego. Well, at least the name close to it, right? Denmark is Lego.
Denmark.
Denmark is Lego.
Yeah. That's from Legoland as a kid.
It's one of the happiest places on earth.
I believe so, yeah.
I'm serious. Come on. Let's not be dissing the Swedes. They have great fish too. Swedish fish. Did we already establish that Swedish fish is not it's a Canadian?
Yeah.
Oh, that's such bull.
Such a buzzkill.
I like that their packaging is yellow and blue.
I mean, we have similar stuff, but
It's not bad.
Shame. What are guys? Whole life is a lie now. Swedish fish is not Swedish.
They are kind of.
Vote everybody off your team.
They're kind of Swedish.
That was great.
They're Swedish.
Alright, I'll put sports when we get out of it's fun.
Output. As a result.
The right word.
Input that's not putting input to pick what's on. That would be the info part.
But scoring and information, was that to score.
It's more of a physical.
Well,
Yeah.
an input would be like I swung the bat, ran the bases, and then I scored. Would be the result. The output would be the result. You know what I mean? Ran the bases, input, scored, output.
Is there such a thing as positive and negative energy? So passive and negative, but random systems like that?
Thanks for helping.
I did.
She's finished. She's already retired
Is this everything?
on her Virgin Islands.
I started reading the book.
Oh, you have the book?
Pretty hard. Yeah, there's a lot of.
It is.
There's a lot of big words. I had to read it a couple of times to get it.
I'm not gonna lie. It is MBA level stuff from the Wharton School of Business. They like to use a lot of big words, but if you get past the big words, it's exactly what we're talking about. We're just gonna look at it using regular stuff. Are we close to Sharon?
Oh yeah.
Totally. Is that a good statement?
Because you know all the fancy words.
All right. I think I handed out 5 super secret post-it notes. 1, 2, 3, 4, 5. I have 5 systems up here. Only because I went around the room this way. Let's do 1, 2, 3, 4, 5. So let's sort of compare and contrast these systems. Let's look at see what they have in similar and what they have in different. Without telling the name, again, a little tension in the room. Oh my God, what is it? You guys decided if it's natural or human-made. So what do you guys think?
It occurs naturally in the environment, so it's natural.
Natural. Natural, human-made. Human-made. So what are the chances that these two systems are actually the same thing? It could occur, but as long as we're using our vocabulary right? Natural and human. You did it, that's fantastic. Let's just say, for now, we've differentiated them. That they appear to be different. They're in different boxes of the universe. Cool. How about number 3? Natural and human. Human. I'll ask the same question. What are the chances that those two systems are exactly the same thing? I actually handed out two post-it notes with identically the same system. I guess it's true, right? We haven't differentiated anything. 4.
Human.
Human. 5.
Human.
Oh my god. I randomly picked 4 human systems, only 1 natural system. You guys are the odd person out. How about physical conceptual? Physical. Go around. Physical. Oh my gosh, they're all physical. Physical.
We're not sure.
I was like,
We're gonna say physical.
yeah, we're going with physical.
Yeah.
Physical.
Final answers. We're not.
They're all physical systems. We've done no conceptual systems. Static or dynamic? Stays still most of the time, moves most of the time. Dynamic. Keep going.
It's kind of both, but I guess we're gonna go with dynamic.
I like that. Yeah, I like the kind of both.
Kind of both, but dynamic.
Oh, I must have been handing out the same thing to everyone. Number 4. Dynamic.
Definitely both with dynamic.
So these first 3 really don't help us to differentiate and identify what it is. Closed or open? Open. Open. Clearly open. Closed. Dun, dun, dun.
Open.
Open. Open.
Open.
Open. Couple changes. 1 closed system, 4 open systems, 4 human systems, 1 natural system, and then everybody else is the same. Are we ready to guess what everybody's system is? Do we have enough information?
Yeah.
Really generic. Again, just to help us out. Maybe the inputs will help us to decide what it is. Can you guys give me a couple of your inputs?
Friction.
Friction is an input. Did you classify that as energy, material, information?
Energy.
I'll just put an E next to it. Like, give me a couple other ones, or whatever else you have for just inputs.
Air currents.
Currents of air. Energy, material, information.
Try not to give it away.
Energy.
Another big
Big
bag. Like uniform.
Energy.
So your system is the energy, the giant ball of energy. Fantastic. Give me another one. You want to third? That's good.
No, I'm
Three.
gonna say what kind.
Number 2.
Then we're getting very specific.
A clicking. Clicking. Energy, information, material.
We define it as energy.
Energy. Clicking. Now, I didn't forget what I gave you guys. Now I'm really intrigued. Do you have another input? Do you want to
I guess we would also say friction.
friction? Energy, material, information. Same, so the same friction part. Do you have another one or just 2?
That's all we have.
That's fine. Clicking, energy, friction, energy, friction, energy. That was natural, so I guess these guys are the same. Number 3, couple inputs.
Energy, sound waves.
I'm sorry, what was the first one?
Energy, sound waves.
Sound waves. Energy. Any others?
Like information, like what I'm gonna say kind of gives it away.
Yeah, so try to hide it if you could.
Lyrics.
Lyrics.
It's a microphone.
I like that. Group 4. Any inputs?
Energy with power
Power. Energy.
and information with song.
Songs.
Alright, we got rules for
Rules.
information. We got players. Materials.
What is that? Material information or energy?
Material
It's like that.
and energy.
And yeah. By the way, yeah, it's everything's everything. Any other big ones?
Uniform.
Uniforms.
Say, I'll just say a ball.
Material.
Ball.
Material. And
We're
a
not saying
ball.
table kind of ball.
Yeah.
Material information energy.
Material.
Still kind of generic.
Ball.
Nope. Not generic. Specific. Rules, players, uniforms, ball. Power, energy. Any energy? Last one, is it energy free?
Nah, that's mad energy. We shouldn't want to give it away.
Oh.
Mad. So much energy.
Sound waves, energy. The clicking is energy. This is almost so we've gone from complete energy system and natural to no mention of energy and human. So we got the range thing happening. That's fine. Maybe this narrows it down. Typically, whenever as humans we discuss a system with a box, we usually, if we had to name it or we had to describe it or we had to identify it, usually we associate its name with its output. What does it do? What do I get if I use this component? Okay? What does your system do? What is the output? Not how it does it, but what's the output? What's the outcome?
Sound waves.
Sound waves. Really mysterious. Sound waves. How do you classify that? Energy. Energy. Here's a giant ball energy system over here. Any other outputs that you guys have?
Heat.
More heat. Heat goes in, heat comes out. Energy.
That's a good answer.
Any other things?
No.
That's it. Sound waves and heat. Wow. It's quite a party.
Yes, my favorite.
Outputs. Ink. How'd you classify ink?
Sound.
Material.
To keep it mysterious, I guess. Information on paper.
We don't have to be mysterious. Just
Or words on paper.
pictures and words. Yeah, with that. I like that. So I would use system number 2 to put ink on paper and drawing pictures and words. I like that. System 3, what's our output? Again, don't worry about giving it away. Output.
Yeah, sound waves for energy too.
More sound waves. It sounds like this system and this system are very similar. One's human made. Any other outputs?
I guess lyrics again.
Lyrics again. It just punches them back out. That's an I. Your system, what does it do? What's its output?
Sound.
More sound stuff.
We said energy and information.
Yeah, both hard to set, hard to.
And then visual as well.
A visual thing. Visual
Someone
stuff.
else gotta say output stuff.
So energy.
You had it.
That's an I. Last one.
We're gonna say a score.
A score.
Just
Like John Williams' score?
what?
Dun, 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 dun. What do you mean score?
Yeah, you got a point.
Like
Oh!
Like a
Points.
scoreboard.
Like a scoreboard, like points.
yes.
Information, material, or energy.
We're gonna say that's information.
I like that.
Yeah.
And a dirty uniform.
And dirty uniform.
Yeah.
That's material.
Energy, material, information.
Material.
Alright. We have the big 4, which really doesn't do anything other than just tell us, well, look. Maybe we narrowed it down with inputs. Maybe combining the outputs with the inputs, we can decide what things are. Can we guess what this system is? Oh,
Can we put one more output?
of course.
Electricity.
Electricity.
Energy.
Friction, air currents, heat, sound waves, heat, electricity. Does that help to describe it? Has anybody seen this system before? Does it make sense to you guys? You know what the system is, right? Clicking and friction, input, ink, pictures, and words for this guy.
A pen.
Pen,
No.
Ink.
typewriter,
Nah, I'm going with prayer.
printer. Fantastic. Sound waves and lyrics. Sound waves and lyrics.
A song.
Microphone.
I'd say amplifier.
An amplifier of some kind. Amplifier. Like that. Power and songs. Sound and visual stuff like pictures and the like. Like a TV. Rules, players, players, uniforms, and a ball. Output, the score, the numeric score, and a dirty uniform.
That's a tough one.
Soccer.
Soccer, football, it's a lot of generic things, right? Maybe the procedure helps us. We have one more thing, right? Procedure, and how does it work? What's the process? Okay. Can you describe the process for this guy? You can't.
Well, we can give one more hint. A cloudy weather.
It has to be cloudy.
It has to be cloudy.
Is that input, output, or process?
Input and outputs.
Both.
Yeah.
Clouds. Wonderful.
You say it.
Oh, what? Thunderstorm.
Does there have to be clouds? I don't know. I don't think there has to necessarily be clouds. No. Nope.
We were explaining.
I hate when I do sideburns.
I don't know. I guess it depends on what you mean by a thunderstorm. I guess
Well,
thunderstorm.
it helped to guess what was our topic.
Oh, yeah.
So it works. It works. Doesn't matter. I mean, I just go with the end result. That's all.
Then again, it depends on. We have lots of human words for common things. And we can have a thunderstorm that was really crazy. Didn't have any clouds, but I guess it made thunder. I don't know. It was a big bang, or it sounds like a thunderstorm. What did you guys say? Conceptual? You were talking about a conceptual thunderstorm, like it could be human made.
Yeah.
Like the team ran across the field like or as a thunderstorm. That would be conceptual thunderstorm. Yeah, I like that a lot. So yeah, natural, physical, dynamic, open. I like that. There's friction involved. There's air currents. There's heat. Yeah, usually thunderstorms happen after a long, hot summer day, right? Like July or August. And there's lots of sound waves if there's really thunder going on. There's heat, and usually the thunder happens because of the electricity, the shorting out between the electrons in the clouds and the electrons in the ground. I like that a lot. Fantastic. Any process for this system?
I guess we could try to give you a process. Grab item, click item, put on paper, move around. Essentially.
Oh, God.
Yeah.
It was a pen.
Could still
Is
be
it
a
pen?
typewriter.
A pen? A lot of these systems, just pointing to it or seeing it work in process, looking at the system doing what it's doing, then you can sort of say that's what it was. Guys, any process? How would you use this system? How does it do its job?
Plug it into a piece of technology,
Plug it in.
and then you put it in / over your ears and begin to listen.
Headphones.
Is it headphones? Fantastic. I like that. Power and songs, sound and visual stuff. I like that. Guys, process for this guy? How do you use it? How does it do what it's doing?
You load the item with information.
You load it so it contains its container.
Put in.
You put the power and the songs in it.
Actually, plug in one of the other systems.
Okay, you plug in this system to it. So these guys are connected, right? Fantastic.
And then that's how you get your output.
And that's how you get your output. What are we talking about? Anybody guess? You put your stuff in this thing and you carry it around. You may need to plug headphones into it to enjoy it.
Yeah.
And an MP3 player, MP4 player, iPod, yeah, sure. iPod. MP3 player, MP3, MP4. Fantastic. Some sort of. Wait, it's a player, and these guys have players too. Is this just a group of iPods running around? What about this guy? Rules, players, uniforms, a ball, the score, and dirty uniforms. Any guess? You guys want to give a prop? I'm sorry? Basketball? Some sort of ball game, right? Basketball. I heard soccer.
Or football.
Or football. Well,
Or baseball.
or baseball.
Or no.
You could say cricket.
Cricket. Come on, ping pong.
Ping pong.
We did ping pong before.
No dirty uniform.
No
That's the catch.
You don't get your
You could get there.
dirty playing ping pong.
Dive. You could dive to the ball.
Could make some
Rings
dodge.
and ping
I've done
pong
it. I've
balls
done it.
in there.
Dodge
Would
ball.
the process help to narrow what ball we're playing, or obviously just showing the ball to everybody? What's the process?
Get two teams together.
Two teams. You need two teams.
Right.
You need a field.
You need fields played on the
Or
field.
court.
So is most of those. Or court.
A field.
Not a court.
It's not cricket, right? Cricket's a pitching court, so you said not a court. You need a field.
You need an umpire.
You need an umpire.
Scoreboard.
Soccer, football, basketball. They're all what they call I guess referees is basketball. Umpire. Who uses umpire?
Baseball.
Does anybody else use umpires? I just don't know.
I think it's just baseball.
Really? Umpires are big. Well, then that gives it away. There you go. Uses umpires. Do you get dirty in tennis?
If you're on play.
Especially when we play court, yeah. In the dirt. So, this process is useful in describing and thinking about a system once you already know what the system is. It's not very useful or not very. It's a mystery until you see the entire thing to sort of guess at what you're talking about. So we usually use this process of input, process. I'm going to say it's a process. Input, process, and output and environment. We usually use that to describe a system after we already have the system in front of us, after we already know what that system is. It's usually not a method for doing discovery. So the scientific method, I'm going to say it's the opposite of this, but the scientific method is for learning new things that you don't already know. This is not one of those things. This is a process of describing something or getting a deeper understanding of what you think you already know as it works through. This, you guys ready for some inception? This process of describing a system as input and output and a process and environment, what is that? So if I decide to describe, it's a system! Holy crap! Yeah. It's a system of how to think about systems. Okay? So this is a system of how to think about systems. It is a system, not the system. It's not, you're going to break the rules if you think about it different ways. We're constantly coming up with new ways to think about systems. This is a popular method for thinking about systems. Yes, sir.
You could say a school is a system of systems of systems of systems of many, many systems.
Fantastic. So here goes the foot, right? That's everything. Everything is a system, is a system, is a system, is a system. It's just inception to go through. You guys have already stumbled on this. The iPod MP3, MP4 player and the headphones, they work together. Okay, maybe the iPod or maybe your cell phone has a or your smartphone has a speaker. But typically, what we're going to do is we're going to take the iPod and we're going to have the headphones. And the iPod, yes, the headphones plug into the iPod, but the iPod usually gives energy and information to the headphones. Okay? So in this way, we can link these systems together. The iPod is sending energy and information out of it. The headphones are accepting energy and information into it. And then out the other side is where we go ahead and put this sound, okay? And then where do the headphones connect to? What's the environment? Where do the headphones connect to? Your ear. So if I wrap this around, here's the headphones, okay? And then here's the, the giant ear. Okay? The giant monster ear. And then this person's head, in order to make this ear work properly and be enjoyable and know what it is, there's a whole bunch of systems inside here in order for the system to be complete. It's a system of systems, keeps on going. Okay, that's why it's difficult to say, what do you guys study? Well, we're ISBT, so we study everything. That's great, fantastic, nice, true statement. How do you go about studying everything? Well, the way that you go, the way that we choose to study everything is we pick little pieces of the system at a time, and then we specifically pay attention to how they are connected. And then once we go ahead and specifically pay attention to how they are connected, then that will allow us to talk about the entirety of what we're talking about. This is the thing we call music, or listening to music, or enjoying music. It requires a whole bunch of individual things. So we have to talk about these individual little steps inside the box, but in order to maximize the connection between these boxes, we also have to think outside of the box. We have to see how they go together. And then we have this giant environment. It was snowing on Saturday. Did anybody, while you guys were sledding, have your earbuds in, listen to the tunes while you were sledding or snowing? I guess it depends on the environment. If it was raining a lot, maybe you want to get your stuff. But I started shoveling snow Sunday morning with my earbuds in. Got some brand new earbuds for Christmas. They're really good. They're not noise canceling, but I can't hear a thing. So I'm in the middle of the road, and all of a sudden I heard a beep. Like, yo, idiot, can you get out of the road? I didn't hear the car coming because I'm sitting here with my earbuds like, whoa, this is the wrong place to wear a nose. I'm going to get smushed. So the environment was totally wrong to enjoy my fantastically awesome Bose earbud. The environment may be just as important as everything else as far as how the system should be properly enjoyed and properly work. That's what we're talking about. We do have lab this afternoon for the first time. Yay. 1:55 is our official start time. Let's call it 2. If we could start by 2 or so, that'd be fantastic. We are downstairs, relative to where we are now, in H255. For those of you who have been in ISBT for a while, that's our ISBT lab. Yes, sir, Richard. Bye.